Voltage drop is a phenomenon that occurs in any electrical system and affects the quality of the power supply. In this video, we will delve into what voltage drop is, how it occurs, what factors influence it, and how we can avoid problems related to it. In an electrical system, voltage drop refers to the loss of voltage as electricity moves through system components such as wires, conductors, and electrical devices. This energy loss occurs naturally due to resistance in conductors and depends on several factors that we will explore in this video. A classic example of voltage drop is when we turn on several electrical appliances at the same time and notice that the lights flicker or dim. This happens because resistance in the wires and connections causes a loss of voltage, which affects the performance of the connected devices. Voltage drop can be calculated using Ohm's law. The basic formula is voltage difference equals current times resistance, where voltage difference is voltage drop, I is current in amps, R is resistance in ohms. Voltage drop can be calculated using Ohm's law. The basic formula is voltage difference equals current times resistance, where voltage difference is voltage drop, I is current in amps, R is resistance in ohms. This formula tells us that the voltage drop is proportional to the current flowing through the conductor and to the resistance of the conductor. The greater the current and resistance, the greater the voltage drop. Therefore, it is essential to design electrical systems to minimize this loss and ensure efficient performance. There are several factors that influence voltage drop in an electrical system. The most important ones are conductor resistance. Materials used in cables, such as copper or aluminum, have different levels of resistance. Copper cables, for example, are more efficient because they have less resistance compared to aluminum cables. Conductor length: the longer the cable, the greater the total resistance of the system and therefore the greater the voltage drop. This is especially relevant in installations where distances are long, such as in distribution power lines. Conductor cross-section: the thickness of the cable also plays a crucial role. A thicker conductor has less resistance, which helps minimize voltage drop. Electrical current: the greater the amount of current flowing through the system, the greater the voltage drop. In high-consumption systems, it is essential to take this factor into account to avoid overloads and significant energy losses. Voltage drop not only affects the performance of connected devices, but can also cause more serious problems on the power grid. Some of the most common effects of voltage drop include decreased efficiency of electrical devices. Appliances that rely on a constant supply of voltage, such as motors or household appliances, may not operate optimally if there is a significant voltage drop. Overheating of cables and components. When the current increases to compensate for the voltage drop, cables and system components can overheat, which can lead to damage or even fire in extreme cases. Power loss: as the voltage drop increases, so does the power loss in the system, resulting in increased energy inefficiency. Although voltage drop is an inevitable phenomenon in any electrical system, there are several ways to reduce it and minimize its impact. Use lower resistance conductors. Using copper wires instead of aluminum is an effective way to reduce voltage drop due to the lower resistance of copper. Increase conductor thickness. A thicker conductor offers less resistance, which helps reduce voltage drop in long installations or high current consumption. Reduce wiring length. Whenever possible, it is advisable to minimize the length of cables to reduce the overall resistance of the system. Split the load. In larger installations, distributing electrical loads across different circuits can reduce voltage drop and avoid overloading a single line. Install voltage regulators. Voltage regulators can compensate for voltage drops in situations where the power supply is unstable, ensuring a constant voltage to connected devices. In many countries, there are regulations governing the maximum amount of voltage drop allowed in an electrical installation. These regulations are designed to ensure that the electricity supply is safe and efficient. For example, in residential systems, the maximum voltage drop allowed is usually between 3% and 5%, depending on the type of installation. Complying with these regulations is essential to ensure that installations are safe and that electrical appliances operate optimally. In everyday life, we can notice voltage drops in common situations, such as when we connect several devices to the same power outlet. The quality of the power supply can be affected, especially in areas where the facilities are not properly designed. It is therefore important to ensure that the electrical installations in our homes and workplaces are well designed and have suitable conductors to avoid problems related to voltage drops.
In industry, voltage drop can have a much greater impact, as electrical systems often handle large loads and travel long distances. That is why advanced solutions, such as the use of high-capacity transformers, are implemented in industrial facilities to minimize voltage loss in the network.
Electrical engineers play a critical role in the design and implementation of efficient power grids, ensuring that voltage drop remains within acceptable limits to ensure productivity and safety at facilities. With the advancement of smart grids and the development of new conductive materials, such as superconductors, the future of efficiency in electrical systems is bright. These technologies make it possible to reduce resistance in conductors, which can drastically minimize voltage drop in large-scale systems. As technology advances, so do solutions to mitigate voltage drop, making power supply more efficient and reliable at all levels. In short, voltage drop is a fundamental element to consider in any electrical system. From homes to large industries, understanding how voltage drop works and how to minimize it is key to ensuring an efficient and safe power supply. Whether by using appropriate cables, designing optimal installations, or applying new technologies, we can all take steps to reduce this phenomenon and improve the performance of our electrical systems. Thank you for watching this video. If you liked it and want to learn more about electricity and its applications, don't forget to subscribe to our channel and turn on notifications so you don't miss any content. See you in the next video.